imagine if you were an alien who, was visiting the Earth for the first time from some other galaxy. Imagine only visiting the United States and never visiting any other part of the Earth's surface. That's essentially what we've done with the Apollo missions. Really been able to do wonderful and groundbreaking science with the samples, collected during the Apollo missions. But again, we visited only a very small part of the lunar surface.
The way that I think about it is it's the equivalent of landing on Earth and getting rocks from Kansas. It would give us insight into one particular location on the Earth, but not at all the diversity of what we see on the Earth, what we know is present on the Earth. So the ability to go to a different site, a different location, get different samples will just enrich what we have already learned from our Apollo samples.
There's a lot left to be learned about the moon, and it starts with the South Pole.
Artemis astronauts will fulfill a different mission in a unique environment. While the Apollo astronauts who visited the moon's surface between 1969 and 1972 landed near the equator, Artemis astronauts will venture to the moon's south.
Important things like drinking water for astronauts and even rocket fuel to take them back home. So really understanding these resources and how to use them is one of the objectives of the Artemis program, and it's what makes the South Pole of the moon so exciting.
We know the moon in incredible detail, thanks in large part to NASA's Lunar Reconnaissance Orbiter, or LRO. LRO has been circling the moon since 2009. It's the longest-lived spacecraft there. Through tens of thousands of orbits and data from 7 instruments, LRO has mapped the moon's temperature, geology, radiation environment, and is providing insight on how the moon is changing over time. LRO is led by Dr. Noah Petro, a planetary geologist at NASA's Goddard Space Flight Center.
LRO is this incredible mission. It was launched in 2009 as the opportunity to go back to the moon, to create this three-dimensional, high-resolution, high-definition atlas of the moon. Where are there safe landing sites for human and robotic explorers? So what LRO is doing is really giving us the tools, the material, the data we need to make those missions successful.
For many years, LRO's elliptical orbit was closest to the moon during the spacecraft's pass over the South Pole. So scientists have more information about the South Pole region than any other region of the moon.
We know that we can do more and build upon the legacy of Apollo, but to do that we needed a higher resolution data set. We wanted to know where the hazards were. We wanted to know where the geologic features were that we want to go explore, and so LRO has created that database. Incidentally, the LRO data volume is now over 1.3 petabytes. It's the largest volume of data that NASA has ever collected from any planetary body. It's remarkable. And what we've done now in support of Artemis, in support of other NASA missions to the moon, is we've created special maps. We share them with the public and we share them with the various engineers and scientists who are going to help enact and make Artemis a reality.
This is basically a Google Maps of the moon, taken from pictures from the Lunar Reconnaissance Orbiter camera, and you can just zoom in and see a 5-meter boulder on the surface of the moon. That's just crazy. I could spend all day, and I have spent all day, sometimes just browsing around different parts of the moon, just looking at air rocks.
This wealth of information will make it easier to find ideal locations for a NASA base camp, and to quickly identify scientifically interesting areas to visit nearby.
So it's my real belief that we have an opportunity with Artemis to do something different than Apollo. We build on Apollo, we learn from Apollo, but we want to expand what Apollo was able to do and build this presence on the moon that is more than just 3 days, more than just 6 individual missions, but a much larger program that eventually will result in the ability to go onto Mars.
Mars is quite a bit longer away from our own planet than, of course, the moon is. It takes several months in some cases to get to Mars, and it's therefore going to be really critical when we have astronauts walking around on the surface of Mars to be able to stay there for longer periods of time. You've just spent 6 or so months to get there. You want to really be able to explore the surface around you, and having the ability to live off the land and know how to conduct exploration for longer periods of time is going to be critical for Martian exploration, and lessons learned for that sustainable type of exploration start right here at the moon.
So there's still so much for us to learn from going back to the moon from a scientific perspective. It's a no-brainer in my head. So with Mars in the horizon as our kind of end goal, this is an important step for us to take. And then also just kind of from a human aspect, we all have this kind of intrinsic desire to explore. I think it's in all of us and certainly in us as a society. And so I think setting our sights on something and accomplishing this goal together is really important just for international relations, for, just coming together as a humankind, the human spirit. I think that's a piece of what we're doing that we can't ignore as well.